Okay, so in math, what does difference mean? Like what operation means difference? Subtraction, yes. So we're going to have subtraction of two perfect squares. So I'm going to take a second, and in this little space we have, I'm going to write down some perfect squares. So you get a perfect square when you square a number. So you can do 1 squared, which is 1, 2 squared, 3 squared. Just keep squaring numbers. So you have a pretty long list. We can't list all of them because there's an infinite number of them. All right, so I went all the way to 12 squared. And you guys can always create this list. Do you need this? Okay, you got it. Okay. You can always create this list with a calculator. Just start squaring numbers. That's fine. You can also tell from your factors pairs which numbers are perfect squares. I'll let you guys get that written down, and then I'll show you what I'm talking about. When a number is a perfect square on this factors pairs chart, the very bottom numbers, if it's something times itself, that means it's a perfect square. So here on 4, we have 2 times 2. That's 4 is a perfect square. 3 times 3, 9 is a perfect square. 7 times 7, 49 is a perfect square. 6 times 6, 36 is a perfect square. So you can use your factors pair chart to test if something is a perfect square. Just look at the bottom. If it's a number times itself, and it's a perfect square. Okay, so on number 20, sorry, let me give you the rule. So when you have the difference of two perfect squares, it'll be like a squared minus b squared. To factor that is pretty easy. You're still going to do 2 parentheses. And then in the parentheses, you do each square root, one with a plus and one with a minus. And that's all you have to do to factor it. So just recognize that it's a perfect square, find the square root, and just do one with a plus and one with a minus. All right, so for number 21, are both of those perfect squares, x squared and 4? Yes. So we're going to use this new rule, difference of squares rule, where we find each square root, which is going to be x. And then what's the square root of 4? 2. So we do x and 2 in each set of parentheses, and we just do one with a plus and one with a minus. That's it. Now, it can get a little more challenging with the variables, but that's basically it. So in 22, there's subtraction, and they're both perfect squares. So we can use our rule where we'll just find each square root, so y and 9, and do one with a plus and do one with a minus. All right, then this one. 9 is a perfect square. We can double check it by looking at 9. 3 times 3 is 9. 25 is a perfect square. We can double check it. So, and it's subtraction, so we can factor it by doing our 2 parentheses. Now, the square root of 9x squared is going to be 3x. Right? We know the square root of 25 is 5. What about that y to the 4th? Do you know how to find the square root of y to the 4th? It would be y to the 2nd. You do one with a plus and you do one with a minus. I'm going to go over to the side and make a note about variables that are perfect squares. So any variable with an even exponent is a perfect square. So y to the fourth, y to the sixth, y to the eighth. Any even exponent is going to make the variable a perfect square. And then you're going to need to be able to take the square root. So to find the square root of a variable, take half of the exponent. Now, obviously that's only for variables. That's not how you do the square root of numbers. It's only how you do the square root of variables. Okay, so let's look at number 24. They're both perfect squares. This is a perfect square. This is a perfect square. It's subtraction, so we can do our little shortcut. All right. And then the square root of m squared is just m. And then the square root of n squared is n. So that's going to be mn. What's the square root of 49? 7. So we'll do 7, 7, 1 with a plus, 1 with a minus. Okay. Let's look at 25. Are those perfect squares? 72 and 2? No. But is there a common factor? 2. So we always need to be checking for that first. I haven't been saying it every time, but I should have been. So there's a common factor of 2. So we're going to factor out a 2. All right. Then now they are perfect squares. The square root of 36 is going to be 6. And then what about the square root of r to the 6th? I'm just going to take half of that exponent. It's going to be r to the 3rd. All right. And then plus the s and minus the s. Right. Now, this very last one is a good review of factoring out a common factor when there's a bunch of common factors. So between the numbers, it's obviously going to be 2. But what else do they have in common? A's and B's, right? So this one has a squared and this one has a to the 4th. So what does that mean I need to factor out? The smaller exponent or the larger? Smaller. So we're going to factor out a to the 2nd, the smaller exponent. And then they both have a b. So we're going to factor out b. So what do you get when you factor something completely out? You have to write something. It's like you divide something by itself. What do you get? 1. So that's going to be a 1. And then on this one, I'm going to divide 32 by 2, and I'm going to get 16. And then when I do a to the 4th divided by a to the 2nd, we subtract those exponents, and we get a to the 2nd. And then what about the b's? The b's are gone. The b's completely factor away. All right. So that 2a squared b just hangs out on the outside. And then is 1 a perfect square? Yeah, because 1 times 1 is 1. So we do 1 and 1. We do plus and minus. And then the square root of 16 is 4. And the square root of a squared is a. And that is it. All right. What questions do you guys have? Okay, I'm going to hand out your homework, and we're going to fill out this little chart together. So hold on just a second. Do I want it? No, it's your notes. Hey, Jackson. She needs a paper. Okay. So what is the very first thing you always do when you're factoring? Greatest common factor. So that's the first thing we're going to do. Check for a GCF.
Here's the wrong paper.
Oh. Okay, hold on a second. What did I do? Hmm. How many do you guys think? Okay, check for a GCF. And then one of two things is going to happen. You're either going to have 2 terms or you're going to have 3 terms. If you have 2 terms, you're going to try and see if you can do what we did today, which is we're going to check for difference of squares. So that means you would need to have 2 perfect squares that are subtracted from each other, and then you can just use this little shortcut to factor them. If there's 3 terms, there's 2 things that could happen. It could be one where there's not a number in front of the x squared. So x squared plus bx plus c. When it's that situation, you're just going to factor normally. Or it could be one where there is a number in front of x squared. So ax squared plus bx plus c. And on that one, you're going to slide, divide, bottoms up.